Alright, so let's take a look at how we can use conjugates to create a polynomial. Okay. Before we do that, let's just take a second. Let's just read this one. What's a third degree polynomial function, y equals p of x, with rational coefficients so that p of x equals 0 and it has roots of -4 and 2i? Okay. Let's just take the bottom of this paper here that is completely blank to just do a little bit of small review here. Okay. Here's a little bit of the review. Do you remember this question that you got earlier on in the unit? I'm thinking of a polynomial function and I have zeros of, say, I don't know, -2 and 3 and 1. What was the polynomial function? Didn't you end up going and doing this? X plus 2 would be a linear factor, x minus 3 would be a linear factor, and x minus 1 would be a linear factor. And then what you ended up doing there is multiplying those together. Can I stop at this point? Because then what you do by multiplying all those together is coming up with that polynomial function. Okay, so essentially, well, literally, that's exactly what we're doing right here. We are making a function. The only difference now is before you were doing it when all the roots were real. Now, what happens when we have to do this when some of the roots are not real? Okay, that's the first lesson. Second one goes back to working with imaginary units, right? And think about this for a second. If I were to give you the square root of -1. Remember, the square root of -1 by definition is I, right? So that allows us to say, well, the square root of -4 is no different than the square root of -1 times a +4. So the square root of 4 would be, which we can do there, and then we can take the square root of -1, which then would lead us to 2 and then I, right? So square root of -4 would be equal to 2i. Now I want to pick back on this the square root of -1, this I business here really quick. What would happen if I were to square both sides? What would happen over here on the left, on the right, obviously we'd get I squared. What you're getting over here on the right, when you square a square root, squares and square roots are inverses of each other, so they undo that operation. So all you're left with here would just be -1. This is one very, 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 very important fact that we're going to use here in a little bit. So if we have I squared anywhere, we can replace I squared with a -1. Let's look back up here at this problem. So if we have roots of -4 and 2i, the conjugate root theorem tells us that if 2i is a root, then -2i must also be a root, right? Because remember, 2i is no different than us saying 0 plus 2i. And the root theorem tells us that also 0 minus 2i must be a root. So there's your 2 right there. But since -4 is completely real, the conjugate root theorem doesn't apply. So if 2i is a root, and -2i is a root, and -4 is a root, see how they handle -4? No different than before, right? And then look at how they handled the 2i and the -2i. Notice they handled it exactly the same way. That -2i, think of that guy as being this one right here. That 2i, think of that as being this guy right here. So still play that opposite game there. Okay? Now what the textbook goes into here is multiplying these together, which I kind of didn't like, so I completely blanked that out, and I want you guys to follow along with me here. I want to show you how they got from here down to there. Okay? Realize that this x plus 4 is going to be down there, so what I'd like us to focus on here temporarily, at least at first here, let's just worry about this guy right here. Let's multiply those together. Let's first outer inner last this guy here. So whether you're doing this with a box or you're doing it with arcs, either way is fine. So x times x, doesn't that give us x squared? And then x times a -2i. Wouldn't that be -2? I'll write the x next, and then I'll write the I last. Inner, wouldn't you get a +2 and then an x and then an I? And then last times last, wouldn't we have a +2 times a -2, which would be -4, and then we'd end up with I to the second power. Interesting. Put that in parentheses. Right there, and just that right there, is just the same stuff in yellow. Keeping in mind, right, that we still have this x plus 4 just floating over here, just kind of hanging out for a while. Don't forget that he's there, because we're going to need him and put him down there. Okay? But let's simplify this expression here. Notice what happens right here. I don't care if these are imaginary or not. They're opposites of each other. And when you combine like terms that are opposites, they're going to add up to 0, aren't they? I'm going to end up with 0xi. And even if you have an imaginary unit, 0 times anything, even imaginary units, is still 0. So look at what I have now. Now I have x squared minus 4i squared, still times that x plus 4. Okay? I'm going to highlight this in yellow because I just want you to keep in mind that this is all this work right here, and x plus 4 is just kind of along for the ride. Now, remember this down here? That I squared is equal to negative 1. We can do a replacement here. If I squared is negative 1, then really what this is saying is x squared minus 4 times a negative 1, close parenthesis, times that x plus 4. And if I have that, aren't I really taking a negative 4 and multiplying it by a negative 1, which ultimately changes that to a plus 4 right there? Okay? Now, do you need to demonstrate all these moves right here? I don't know. How many moves would I have to ask you if I wanted you to take, say, x plus 7 and multiply it by x minus 7? I got to believe that many of you would just jump right down here and say x squared minus 49, Mr. Cook, boom, drop the mic. Well, why couldn't you do the same thing on these ones? When you have x plus 2i and x minus 2i, why couldn't we just call it x squared plus 4? I don't see anything wrong with that. Okay? But if you don't feel comfortable doing that, realize that your foiling is your only other option there. Okay? So let's take a look and do this problem here. Now, I want you to make a correction to this note sheet. Here's what I would love for you to do. Honestly, if we had to deal with this root of 2 minus 3i, our heads would explode. So do me a favor. Grab your pencil and get rid of that 2. So now I have 3 roots here. There's negative 3i, there's the 8, and dos. Okay? They want us to write a quartic polynomial with those. So, based off of what we know, we cannot have negative 3i without its buddy, positive 3i. So 3i must also be a root. So, when we write out our factors have to look something like this. X plus 3i, x minus 3i. Go ahead and put those side by side. You're going to want to. And then x minus 8 and x minus 2. Okay? So now it's time to multiply those together. I highly recommend you multiply those together. And I highly recommend you multiply these together. I do not recommend mixing the i's with the non-i's, the imaginaries with the reals. Okay? So, if I lost you on that quick move right here, many of you might be able to look at that and say, ooh, that's x squared plus 9. You are right. So let's go ahead and find out why that's x squared plus 9. First times first, outer, well, outer would be minus, right? 3xi. Inner would be plus 3xi. And then last times last would be minus 9i squared, right? Like terms, oops, it's a different color. Like terms, add up to 0xi. So then we'd have x squared minus 9i squared. Hey, how about that I squared? Isn't that I squared negative 1? So it's essentially saying negative 9 times negative 1. So that's why we have x squared plus 9. Okay? Now, look who's been here waiting this whole time. Okay? Who's been waiting this whole time is all this stuff here in blue. Let's go ahead and FOIL that. Okay? So wouldn't that be x squared minus 2x minus 8x plus 16? Like terms, x squared minus 10x plus 16. I don't think much changes. And so then right down here we can copy that down of x squared minus 10x plus 16. Now how do you suppose you think we're going to multiply these together? You got it, just the same way we did it in previous units. So how about we grab that x squared plus that 10x plus 16, and let's put some math in a box. Let's drop x squared and then a positive 9 right there. Let's start filling some stuff in here. So we have x squared times x squared, that's x to the 4th, minus 10x to the 3rd, that's 16x squared. Multiply all those by 9, so now I have 9x squared minus 90x. 9 times 16, yikes, I might have to bust out a calculator or just simply pause it. Oh goody, 144. All right, now let's look for some like terms. Interesting. I think the only like terms I can actually see here are u and u. That's about it. Let's double check. Yeah, I think that's right. So, the polynomial function that would give us those as the roots, we'd have x to the fourth minus 10x cubed, 9 plus 16, wouldn't that be 25x squared, minus 90x plus 144. So there's our function. And that's how it's done, ladies and gentlemen. That's pretty much all there is to know about 5, 5. I trimmed it down to pretty much just that stuff there. So work the conjugate theorem, use the conjugate theorem to get the missing roots, and then multiply those together.